We've got Jim Christensen next, who's going to be doing, well, first of all, talking to teachers, talking about personal development with teachers. And we'll do a little bit of a Q&A after that. Jim, are you here? Are you with us? Oh, we are there. Jim, thank you very much. You are there with your wonderful Aldrin Foundation backdrop.
Well, thank you very much.
Whereabouts are you?
I'm in Titusville, Florida.
We've had people.
I'm about 10 miles from where the rockets are launched. My house, I watch launches from our backyard.
Your kid, see, I am very envious. So you can sort of pad 39A, that's the famous pad, isn't it?
Yes, it is.
Which I'm still very happy is, because I grew up with Apollo, so pad 39A had this great significance. And it's lovely to see that same point on Earth featuring so heavily in human spaceflight.
Dallas, you don't look old enough to have grown up with the Apollo missions.
I have a very expensive moisturizer that I use, Jim. It's very, very expensive. And I also have a portrait in my attic, gradually rotting away.
Well, I'll tell you what, every person that's walked on the moon walked within 10 miles of my house. They probably ate at a restaurant that I've been in, because this is the Space Coast.
Hey, I've got a question. Wolfie's Diner. Do you know Wolfie's Diner?
I don't know that place.
Cocoa Beach. I think it's closed down. But it's very famously, I think, where Gus Grisham went to buy a corned beef sandwich and stuck it in the pocket of his spacesuit and launched on Gemini, whatever it was, and forgot it was in his pocket.
Actually, Wally Schirra was the guy that snuck the corned beef sandwich along and raised absolute terror with NASA. But yes, that's a great story.
I use it all the time. I use it all the time, but I've been mistelling it for the last 20 years. So
you know something? It's a great story nonetheless. And I'm sorry to correct you on that. And you know something?
That's okay.
Maybe somebody will pop on and say, "Hey, Jim, that's not accurate," because these stories take on a life of their own.
I know. I like kind of space history for all those reasons, for the kind of slightly odd, slightly bizarre stories. Hey, listen. So you've got a presentation. I think you're gonna take us through some bits and pieces.
Yes, sir. I do.
Great.
So I'm going to be I'm talking to teachers right now, and I've been really looking forward to that. I just want to say that I had the best time listening to your last guest, and some of the things she talked about. I just want to comment one thing. Yes, indeed, there's a Tesla on its way to Mars. I saw it launch.
And what did you, just very quick before you start, what did you think of that? Because the opinion is divided very often when Elon Musk is in the news doing a stunt. There are those who, really kind of love Elon Musk and like, yeah, it's all fantastic. And then the others are like, whoa, no, this isn't the kind of thing that we should be doing. And I know there's a slight pendulum of opinion.
Well, the truth is, he was testing his Falcon 9 Heavy, and had to carry something, and he could have put tanks of water in the top of it, and for what purpose? And here's a chance. Here's this incredible marketing opportunity, and so he takes his own Tesla Roadster, which is a really cool looking car, red, of course, puts a mannequin of an astronaut in it, and sets up a camera so you can see. They called him Starman, of course. Tesla and Elon just don't miss a trick, and they have all these pictures, and it is in fact on its way to Mars. It's not going to fall into orbit. Who knows what actually happens to it?
There is. It's funny actually. There is something of the showman about Elon Musk, and going back to the Apollo days, people like Wernher von Braun, of course, the great German rocket scientist, who again, used his personality and worked with people like Walt Disney and Willie Ley and all these great entertainers to really get space travel into the public consciousness by doing all these kinds of stunts. And I kind of see that sort of parallel between sort of von Braun and Musk.
Yes,
a little bit.
It's Elon Musk, and that really gives me my segue to get started.
I should shut up actually, because I'm not really meant to be asking you questions. I don't know what I'm talking about, to be honest.
First, I just want to say it's such a pleasure to be here. And I wish I could have been there in person. I was a year ago. I'm reminded by my Facebook that a year ago I was in the UK, And it was just an incredible experience, wonderful people, beautiful place. I'd actually been in the UK 3 times before that, but I never had the experiences I had this last time. I just had so much fun, met so many people, went so many places, and had the opportunity at one point to hold a piece of wood about the size of a broken pencil that had been taken from an apple tree in Isaac Newton's front yard. And I was pretty amazed by that. So anyway, okay, I want to change my view so I'm not just looking at my plain face there with. So I'm here to talk with teachers, and I'm here to talk about the challenges that we face and some of the things that we can do, or that the Aldrin Family Foundation has put together to help teachers. First, I'd just like to say, I'm Jim Christensen. I was a middle school science teacher for 18 years. I had both the fortune and misfortune of being recognized for it. I was awarded a national teaching award, and I left teaching. And that's what happens, is that as soon as you get an award, all of a sudden you're called on to do all these other kinds of things. And I was never assigned a classroom again. And I love teaching, and I still do love teaching, and I love kids. But I went on, and I was at the state level in Iowa, in the middle of the United States, for 16 years. And during that time, it occurred to me that what I really always wanted to be was an astronaut. And I thought, they're not looking for teachers. You have to prove to NASA that they need you, and that you can add something to them. Well, right at that time was when video conferencing was first emerging. And so I came up with this idea: take me or somebody like me, put me on space station, and let me teach lessons every day. And so what I did was I created video conference programs where I would be the moderator, and I would sit with an astronaut at Johnson Space Center, and I would moderate discussions over a distance with these astronauts. And we had an entire program where in advance we'd set the goals, we'd send out materials, we'd have activities for kids, we'd do the video conference, we'd have follow-up activities, and then we'd encourage the schools, the kids, the classrooms, to connect with each other via video conferencing and show what it is that they created as a result of the experience. Well, NASA liked it. And I did a bunch of these. I did like 70 of them. And NASA ended up giving me a job in the Teaching from Space program office that was originally created when Krista McCullough was going to go to space. And they gave me the job of leading a team to develop the ability to do video conferences from the space station to classrooms. And of course, I was hoping I'd get to be the guy. Well, over time, all kinds of shifts, and my son was getting ready to be in high school and play American football, and I was gone all the time, and I ended up saying, okay, family, astronaut. And I chose family. Now, I may never have been selected, but it was certainly an adventure while I got to do it. So I was down there in the astronaut office. I went back and finished working at the state, and then retired, came down to Kennedy Space Center. I was director of education at Kennedy Space Center. If you ever get a chance to visit the visitor complex, there's a building there called the Astronaut Training Experience that I was the lead in designing it. And it's really fun because you can go in and you can spend 5 hours and train like an astronaut. And I know what they do. I was in that office, and we picked out the fun stuff. You know, I didn't pick out the study the manuals kinds of things. The other thing was, we've got a second part called Mars Base 1, where you spend 7 hours, you travel to Mars, you operate a Mars base with a team for 3 90-minute segments, you have lunch, and you return back to Earth. And so I highly encourage you. Okay, so time is going so quickly, and I should get so that I can see, because I've spent half my time and I haven't said anything yet. We have a significant challenge. First, here we've got students. We want to inspire them, but we also want to meet our goals. And that's a pretty good trick sometimes. You know, it's a challenge with kids. I haven't had a classroom since the 1990s. So, hey, I'm way out of it. And I recognize that when I taught, teaching was a lot like juggling, and that you were keeping track of all these things. You know, you're keeping track of your lessons, you're keeping track of every student and what their needs are. And so when I try to build activities, what I try to do is come up with things that will engage students and meet a lot of different needs within a classroom. Now, we've come up with a couple things here at Aldrin Family Foundation. And I should mention, Aldrin Family Foundation was originally set up by the second man on the moon, Buzz Aldrin. And now Andy Aldrin, Dr. Andy Aldrin, his son, is the president of the foundation. And what we have as a mission is to inspire the next generation of space explorers. We actually work with K-12 students, and I'm in charge of that part. And then we have the Aldrin Space Institute that actually does studies on going to space and exploration, going to Moon and Mars. And then we also have a segment where we provide scholarships, and we have classes for graduate or undergraduate and graduate college students. So we've got all these things going, this full range, this pipeline of activities going on. But I'm going to talk about the K-12 things that we do. And so the first thing I'd like to do is I'd like to get out of my full screen so I can see. Pardon me, when we came up, I lost some of my controls. I'd like to show you some of the things that we have. And the first thing I'd like to show you is our moon map. Okay. And there we go. I feel like I'm a television weather person here. I've got this on green screen behind me. What we've created is a 25-foot by 25-foot giant moon map that we distribute out to schools. And with this, we have activities. And why the moon? Well, we're the Aldrin Foundation. We have family members that have walked here. I actually have a video that I'd like to show you that talks about how far it is to the moon. So we have a gentleman, Sam, that if you'd cue that, the moon video, the Earth-Moon scale. Okay, so if you have a globe, and if you roll that globe 10 times, that's the scale distance between the Earth and the moon. Now, it turns out that on the Earth, the size of the moon to the Earth is about 2,000, well, it's about 2,000 miles in diameter. And so that's actually the distance from Chicago to Los Angeles. I was just looking up on Google Maps, and it's about the same distances from London to Moscow. So that's the size of the moon. So if you can come back to me, Sam. I've got this globe, and I've got a model moon that, okay, let's find, well, finding London on the map's a little bit tough, but there we go. And oh, you can see the effects of green screen. You can see right through the Earth. But this would be the scale size of Earth to moon, and 10 times 10 rolls of the Earth, the distance. Now that actually works out so that it takes 1.25 seconds for light or radio signal to get from the Earth to the moon. And so what I did was I asked one of our students to kick a soccer ball. And we got it so that she could kick it so it would go about 1.25 seconds. So we're trying to illustrate the distance. Now, we also, Sam, if you pull up the video about the moon map, I'll just talk through this. Okay, so here's what a moon map looks like. And it's big, it's beautiful. And what we do is there's all kinds of activities with it. One of the things, we put a timeline on it. And so we've got all the different efforts to explore the moon across this timeline. We've also set it up with augmented reality, so you can aim a device at the moon, at the map, and it will pick up data off that, and then you can manipulate that data. And that is just cool beyond cool. We really think this is a fun thing for kids, and there's a lot of data that we've embedded in here. And we keep working at it. So that's our giant moon map. And I said it was 25 by 25. We also have a 15 by 15 foot size. So anyway, okay, if you could come back to me, I think the video's about over. And what I'm hoping is maybe we can spend a little bit of time and talk questions after this. Okay, we also have a set of materials that go with this. If you go to our website, the aldrinfoundation.org, that's right over the top of my head, at the top of the page, there's a place that says Moon Map members. And if you click on that, you'll see about the Moon Map and you'll see materials. And you can go in there and see the kinds of things that we've created, the kinds of activities. Now, what we found is we have a saying in America, I'm from the government and I'm here to help. and then you say that and then you laugh. But what we found is it doesn't work that great for us to come in and say, hey, we've created all these things and this is what you should do. In fact, people get a hold of these maps and they look at them and they say, I know what I'd like to do with this. And they look at our activities and they say, yeah, that's an okay activity. If I was doing it, I would change it in this way. And that's what we hope you do. That's certainly what I used to do as a teacher. I would always take materials and say, I'm changing this. And that's what we think teachers should do. But we've got these activities that you can do. And also, you can get a hold of me and I'll talk to you about things. Okay, so let's go ahead and go to the next area and let's talk Mars maps. Now, I'm assuming you're looking at me with the Mars map over my shoulder because I'm looking at a screen and seeing. Okay, I think you're seeing me. Okay, thank you. Big Purple says thank you. Yes, I appreciate that. This is what our new Mars map looks like. Now, we changed this because the problem with the big square map is it doesn't fit in classrooms very well. So we changed the orientation to be like a big screen TV. It made sense to me. And we put it so that all the data is off on the side of the map right over here. And we've got about the rovers and landers that have been there. And then we've got a bunch of data up above. And despite the fact that America doesn't believe in the metric system, the Aldrin Foundation does. And so we've got both English measurement and metric measurement on this chart. So we've got all this data, and it's actually possible to just fold that underneath so we have just the map. And on the map, we've got locations, regions, and the places where we've got landers. Now, you want to see the landers, you go over to the chart and you can take a look at the pictures. Sam, how about if you cue up the movie about the Mars map? I've got this kind of cool music. First, Mars, it's interesting in that Mars is significantly different in terms of distance. What we do is we have an activity where we take a string, and if you wrap this, if you say that the sun is the size of your thumb, and you wrap a string 34 times around your thumb, that's the distance to the Earth. And the Earth goes in almost a perfect circle around the sun, but Mars is more elliptical. And what I'm illustrating here is that if you take off, if you launch to the moon, or to Mars, at the moment you launch, it would take 4 minutes for a light or a radio signal to get to Mars. But by the time you land, the Earth has gone halfway around, Mars has gone about a quarter of the way. It's 14 minutes. 6 months later, the Earth is back in its original position and Mars is at the opposite side. It takes 22 minutes. 6 months later, Mars is 3/4 of the way around, and the moon is, or the Earth is on that opposite side again. It's back to 14 minutes. Compare that radio signal time to going to the moon. 1.25 seconds to the moon. Anywhere from 4 minutes to 22 minutes signal time to get to Mars. So Mars is significantly different in terms of distance. So when they talk about the challenges of going to Mars, they're vastly more challenging than it is to go to the moon. The moon is in our back pocket. If you make a scale where you have your thumb as the moon, or pardon me, the sun. Okay, you can't see it. The tip of that pin is the Earth. the Earth is 1 million times, actually, in terms of volume, 1.3 million times less in volume. So if I just took a bunch of Earth balls, if I had about 1 million of these, I could fill up a sun. So a sun is incredibly bigger. And so we start realizing just this huge scale. Well, if you're curious about this activity, you can actually find this activity written up on our webpage. And again, it's Aldrin Family Foundation. If you go to the top, it says Mars Map member, and you'll find it from there. You can find this particular activity. Okay, let's take a look at what the map looks like. Sam, I've got that video. And somehow when I was making this, the focus wasn't great, and I apologize for that. But here's Mars. It's a topographical map. And we've got these features. And one of the things we've got is a globe, an Astro Reality Mars Pro Globe. It's really fun to have kids as they work on the map to have that globe, because you've heard people talk about flat Earth. Well, hey, I've got a flat Mars map. Well, how do you translate that to what it really is? And we love kids to hold on to that. Now, here what you're seeing is, you're seeing a student measure the Earth and compare it to Mars with the very accurate measurement of using your foot. Also, here we've got this chart of the different landers, and I just wanted to give you, I wanted to give my models a little chance to show off. I had a great couple kids that helped me with this video. Anyway, that's our Mars map, and I told you a little bit about our activities. Okay, so those are two things that have been very important to us, our two maps. And I was over at Egglescliff School here last year, and we left two maps with them, and it was really fun talking to all their kids about, and I think I talked to every kid in the school and the teachers as well, and it was just an incredible opportunity. And what I'm expecting is that their teachers probably really made great use of these maps, because what it does is that when the case of the moon, you can look up and see the moon, and the moon is fairly familiar. But Mars, if you look up at Mars, what you see is a little speck of sand. Well, what's up there? Well, this puts place names and features to Mars. And despite its nearing inaccessibility, there's cool things up there, and we literally have a rover running around up there at this moment, and other things on their way at this moment. In February, we've got another rover landing, and so that's pretty amazing. Okay, so the next thing I'd like to talk about is, I'd like to talk just a minute about, there we go, about a program we call Home on the Moon. Up until last March, I was traveling someplace about twice a week. My car was parked at the Orlando airport more than it was parked at home, because I was running all over the place. And then all of a sudden, it all stopped. I like travel, and I like meeting people. And a lot of times my wife would travel with me, and we just really enjoyed this. And all of a sudden, I'm sitting in my office, and I can't go anyplace. And it occurred to me, I might as well be on the moon. There's an idea. What would it take to take my house to have a home on the moon? And I thought, okay, what do I need? I need air, food, actually air, water, food, energy, shelter. That's what I need here. And I have a system here at my house to provide every one of those things. Well, how much am I using? How much air do I actually breathe? How much oxygen? How much carbon dioxide do I produce? How much water am I using? How much energy am I using? How much food? You know, we were ordering our food to be delivered. I was really acutely aware of all these things. So what I did was I wrote up this activity where I asked kids to consider, what is it that you have to have? How much are you using of it? And then, how do these systems work in your house? Because you've got an HVAC system, you know, you've got a way that you circulate air in your house. Well, how would that change if you were on the moon? And I wrote the thing up, I made a backstory and talked about how that we landed on the moon in the 60s and 70s, And now we're back, and we're to the place where we've got a science station on the North Pole and a logistics station on the South Pole, and that we've got an orbiting station. And I gave them names and I gave them acronyms because everything in NASA's got an acronym. Put all this together. I created videos, 5 different videos to explain the project. And we said, okay, design something and tell us about it. And we literally had people from all over the world that signed up to do this. And then I said, well, if you send me your final product, we'll judge them, and as many as we can, we'll give you prizes. And we gave away a bunch of these lunar probe globes, which are just spectacular from Astro Reality. Just love these things. They have texture. I like to have this close. We also gave away a bunch of lunar notebooks, and I'm afraid I gave away my last one, but here's my Mars notebook. Pretty cool thing. But the big idea is to consider what it is that you have to have, and then how does that translate to this different environment? And it was an online project. We just really had nice success with this thing. Now the materials are still out there. It's on our website. I'm not like the weatherman. I don't know where these things are on the screen. aldrinfoundation.org. And you're certainly, it's certainly possible for you to use these materials and modify them as you like. What I tried to do all the way through it is to say, there's lots of different ways to go about this project. There's no single way. You don't have to come up with a particular thing. Now, I actually have a little video that I just sent to Sam just a couple minutes ago. Would you run that video, Sam, the Brook video? This is one of the projects that was made by a young lady down in Melbourne, Florida. And what she did, she worked with her family. Her family sat down around the table and said, well, what do you have to have and how much are we using? And then she started building this model. Now, I also had models come to me that were like online kinds of 3D design software. I had a high school class in Columbia that made a thing that was spectacular, but they did it as a class. I also had a group of adults, professionals, that were taking part in a moon analog study in Krakow, Poland, that sent me this paper. It was about 120 pages long. And so I got this range all the way from very young kids with this idea of, expressing what they would build to adult professionals. And so I had this huge range, but I just wanted to engage people in thinking about this. One other piece of this, and I don't want to oversell this, but everything we do on Earth, when we go to live on the moon, we're going to end up doing those same things. And one of those things is we're going to need to govern ourselves. And how do you do that? That's kind of interesting, the idea of that. Of course, in the United States, we just had our vice presidential debates last night, and you're probably aware of what our situation is here. And it's just fascinating to think, how do people form together so they get along and get things done? Okay, so something to think about with Home on the Moon as well. Okay, one other project that we've got is we have a project called We Came in Peace, the Apollo Visitor Complex Project. Now, know that my background is, I was most recently, before coming on with Aldrin Family Foundation, I was education director at Kennedy Space Center Visitor Complex. And the mission out there is to tell the story, tell NASA's story. And I begin to think, what would happen if, when people start becoming tourists on the moon, where would you want to go? Well, I would like to go to Tranquility Base, and I would like to see what Neil Armstrong and Buzz Aldrin left on the moon. I'd like to see that place. The problem with that is I might accidentally kick dust on the first footprint, because there is no erosion up there. Everything is exactly the way they left it. Now, the word is that the flag got knocked over when they lifted off. And chances are the flags that are left at each one of the sites are probably all faded out or perfectly white at this point, but there they are. And so I thought about, let's ask kids to consider how you would build a visitor complex, a museum at the site of an Apollo landing. And then let's say it needs to tell the historic context of the mission. It needs to explain the science. So if you attend the museum, you know the history, you know what the science was about, and the architecture is such that it honors the mission. Now, that's the art part. You know, we talk about STEAM, we have the arts to STEM, and it really draws on all these different ideas. Now, I don't have any video of this, but we actually put this project online as well, and you can find it again at aldrinfoundation.org. And we worked with a partner named PCG, who has a wonderful online system, and you can find this project. Okay, so I understood that I could go until about 11:44 and then, or 11:45 and ask questions, and doggone it if it isn't 11:45 right now. I love being on time. So are there any questions or comments that people would like to make? I'd love to just talk to you about these projects.
Jim, you're now my new favorite space hero. I so enjoyed listening to your talk. It was brilliant.
You know, you're too kind.
Can you hear me okay? Are you still there?
Yes, yes.
Good. So many questions. First of all, thank you. I want to say thank you for your talk. Thank you for believing in the metric system. That was the first.
It's so easy. I can do metrics.
That was my first thing that I pricked up. Although here in the UK, we're just as bad. We kind of use half metric, half imperial, half other things. Like we still measure things the size of whales, swimming pools, inches, gallons. We're kind of all over the shop. So I sympathize with you.
Yes, yes.
Hey, I've got a question for you. I mean, last year obviously was the Apollo 11th, 50th. And I kind of noticed, I went around schools a bit and gave talks and things. And, you know, most generally people were really enthusiastic, but I did notice there's still quite a lot of anti-science out there, science denial, people who believe we didn't land on the moon and all that kind of stuff. And I'm wondering, like, how you, as someone who's so involved in education, is that, do you get that in America as well, or is that just where we are?
Yes, sadly we do, and of course that ties in. It tends. Boy, I hate to say it. It seems to be there's at least a little bit of a political line with science, but there's also just this sense that, well, how could they possibly have done these things way back then?
Yeah,
and the idea that you could do these calculations with a slide rule. You know, you see the scene in Apollo 13 where they're all pulling out their slide rules, and kids say, "What's that?" And I say, "I used to have one of those things." But literally, my phone has more power, computing power, than was in mission control. A lot more power than was in mission control.
I worked out, I think the computing power of the Apollo guidance computer is sort of equivalent to a musical Christmas card. It's sort of that level of.
Yeah.
But
okay. But in answer to your question, okay, one more story before I totally answer.
Yeah.
When we were doing this Home on the Moon thing, there was a television station that wanted to do an interview with Brooke, the young lady that the pictures, and Brooke she's amazing, just an amazing young lady. And a neighbor walked over as I'm doing this television interview and said, "I don't think they ever went to the moon." What?
But I get
a television interview about the moon.
So when you're talking to teachers, what do you tell teachers? Because teachers are obviously going to come across this. Lots of kids, you know, and well, not just kids, grown-ups as well, watching YouTube videos and things like YouTube videos becoming this source of information, which is erroneous and ridiculous. How do you, I don't even know where we start combating that. For you as an educationalist, where do you begin?
Okay, here's where I start with it. What's happened is science and technology has become so complex that it's indistinguishable from magic. You know, it's just, here's this machine, here's this telephone, and it does all this stuff. How does it do it? I don't know, it just does it. It's inside this black box. What we need to do is make ties. I believe we need to make ties back to, how do we know this stuff? Where did this come from? You know, and link it all the way back to early scientists, and then tell a story that goes from the early scientists to now, and take the magic out of it. Make it so it's understandable. Now, I know that's complex. So in some cases, you have to move back a ways. My philosophy teaching middle school back in the day was, let's figure out things that early scientists did, experiments that they did, and let's do them in class. I think you could all laugh when you think about me doing an Archimedes experiment. Ha ha, there you go.
There we go. We did this earlier on today. Dave Scott, Apollo 15,
Yeah.
Hammer on the Moon. Still my favorite experiment ever.
I think the Air Force would probably take exception to your pink falcon feather.
It's the only one I could find. I was rooting around my house. I'm like, damn it, I don't have a feather. Where can I get a feather from? And I found, can I say appropriately enough, a falcon feather? Nobody's got detail.
But anyway, that's how I approach it. But I get this fairly often because, hey, I represent the Aldrin family, and people come up and do that. Now, if you want to just have a laugh sometime, one time somebody videotaped a person approaching Buzz Aldrin in an airport and said, "You never went to the moon." And Buzz, well, just Google it and watch the YouTube video.
Trust me, Joe, I've watched it many times.
Yeah, it's fun.
It is fun. I'm constantly surprised though at the sort of questions that I get asked. I just wanted to ask you, as someone who's so involved, so deeply involved in sort of education. And actually, you mentioned the vice presidential debate yesterday, and I wonder how much of the sort of politics. Politics has got very messy and very, very polarized and very partisan. And I wonder how much of that sort of that's the difference of values translates across into education from your perspective.
Yeah, it does. And it's a thing that I think we have to I think it's up to mature adults for mature people, because there are very mature children as well, to just recognize that we have a wide range of people and opinions that deserve respect. But we also need to be able to consider, how do we know that things are true? I think the single biggest question right now is, I've seen it on the internet, is it true or is it not true? And to help kids be able to identify and judge the truth of things. And I think that goes back to science and the scientific method. And I think we develop that in kids by practicing the scientific method and valuing that.
That's a really good point. I think very often people don't really understand what science is, and people think that science is a thing or a book of facts. And of course it's not. It's a method and it's a way of doing things. The problem is, I find that very often conspiracy theorists, they sort of have their own scientists because they get their own facts only from other conspiracy theorists. So it becomes this self-sealing bubble. And they of course see themselves as the open-minded one, while you scientists are all closed-minded, and in the pay of some nefarious group of elite people. And it's ridiculous. I don't know. I just don't know quite how to sort of tread that line. But it's interesting to hear your thoughts. I think you're right. Teaching people what science is very good. Just very quickly, you mentioned actually when you're talking about the maps, you talked about when schools or organizations get these maps, there is a degree of flexibility in terms of how they're used. I'm just wondering how what that looks like, that flexibility.
Okay, so what it looks like is, first, if you want to get a hold of a map, there's a couple different ways we do this. And one is we work with donors to fund maps. But the way you get this started is you go to our website, and there's a place that says, "I'm interested in a map," and you click on that, you fill out your information, and we have a person to contact you. But we typically work with donors. Once a year, we do a situation where we donate a bunch of maps. Now, right now, COVID has kind of screwed us up a little bit. And so we don't have that scheduled at this point. I gave away, the foundation, donated a large number of maps here last spring. So we're kind of done for 2020, but it'll come up again in 2021. But what's it look like? Well, typically what happens is you get a map and you can arrange training with me. And right now, the training is probably online. But I go through what's on the map and why it's there. And we try to design the maps with the idea of teachers taking it and running with it. Second thing is teachers will say, what do you do with it? And we'll say, here's a range of activities. And I'll run you through those activities, show you what these things look like, talk about the philosophy of them. And then from there, we say, here's the kinds of things you can do. What would you do? What is it that's hard for you to teach? And is there a way to use this map? Because the map is highly motivating. The thing's just beautiful. And it's so big, it just kind of takes your breath away. Where can this map help you? Funny thing, my wife taught in the 4th grade. She taught like 10-year-olds for 33 years. And the first time she saw a map, she laughed and says, I know what I'd do with that. I said, what would you do? And she said, I always had trouble teaching latitude, longitude. I'd use it for latitude, longitude.
Yeah.
Oh, of course you would. And I think a lot of times teachers say, here's this tool and here's how I use it in my class. So that's how I think it looks.
I think that's a really good idea. And I also really liked your idea of thinking about visiting the Apollo sites in your imaginations. And if you were to set up a visitor center, and I know there is a NASA document it came out about sort of 20 years ago. And it was quite a speculative document about, okay, for spacefaring nations, if you're returning to the moon, how would you treat these sites? Because obviously these are sites of historical importance. And exactly as you say, things like making sure you don't disturb the footprints and, but there's also interesting science to be done as well, like the retroreflectors. Could we clean some of the lunar dust off those and reuse them again? And things that could be done. And also, actually, the amount of sort of archaeology that could be done on those sites as well. Things like the feather. That feather is still up there, What's happened to it? How is the environment of the moon affected a biological specimen like it? All these are interesting questions, I think. I think there's a wonderful thing that you could do exploring that idea further. It's great.
Yeah, I think all those things, I'm fascinated by that. And it's interesting you say a paper came out about 20 years ago, because here I think this is a new idea. No, it's not. Years ago, back in the mid-90s, I created a project called Mars Base Project, where kids would they'd work as teams and they'd build these Mars bases, basically out of recycled items. And then we'd video conference and share them between schools. And it was a really cool thing. It's one of the things I was doing, kind of the idea of becoming an astronaut, prove that you could use video conferencing to teach. Back when video conferencing was magic. And we'd come up with ideas and somebody'd say, I wonder if NASA ever thought of that. And I had several NASA contacts and they'd say, yeah, there was a study done back in 1963 and there aren't many new ideas. They just come around in new contexts. Yeah. But we keep having them, it's fun.
Hey, listen, that's a great session for teachers. And I hope teachers will have listened to you, and you've got such wonderful enthusiasm. It's just terrific to hear you talk. Now, I know you're going to do another session now, aren't you? A sort of family session.
I am at right up, well, for me, 12 noon, for you, 5 o'clock. This is proof that it's 5 o'clock someplace.
It's definitely 5. So we definitely know the Earth isn't flat, because it's 5 o'clock here and noon where you are. But
I should be taking out a drink.
Yeah. Well, listen, I think we're almost there. We've got a couple of minutes there. So what I might do is, I'm just going to check to see if we've got any more questions.
Okay.
So yeah, this is from Nick, actually. Well, Nick, who I know very well. Thanks, Nick. So Nick says, surely they have to leave the Apollo sites well alone, but great points on the archaeology. I agree. I mean, I think particularly the Apollo, there are certain sites, Apollo 11, for example, and Apollo 17, I guess, which have very specific, historical significance. They absolutely must be left alone.
Well, this picture that I pulled up, this is a picture of Apollo 15, and that rover is sitting up there just wanting to be driven.
That's right.
Now, also, probably dead.
I want to know about the Apollo 15 rover. So this stuff, some gaffer tape. I know the mudguard of the Apollo 15 rover is held together by gaffer tape.
Well, let's see if you can actually see that on this picture.
Well, maybe because basically they used the cover of one of the flight manuals, I think, and gaffer taped it on because it came off. But as a material scientist, it would be interesting to see how things like gaffer tape has survived over 50 years. You mentioned the flags as well. Obviously, the flags will probably be bleach white if there's anything left of the flags at all.
Yeah.
But
Yeah.
these are all interesting questions. Nick's also said, this is a good one. Find the golf ball from 14. Yeah, who was doing the golf ball? Was that John Young? I can't remember. Al Shepard, sorry, of course. Al Shepard.
There are a number of golf ball companies that would love to know if it was their golf ball.
Exactly. There are some good. Yeah, I believe it's in Javelin Crater. I think is one of Al Shepard's golf ball.
I'll tell you what, you know a lot. That was a big fairway and a big green he could get us.
And Nick's also said, yes, the Rover from 16, see if that can be restored by a battery swap. Yes, duct tape can survive anything. There you go. So there we go. There's my little pot of moon dust, which I always carry around with me just in case. You probably got some as well. Oh, you've got some. There we go. Look, we're the same. You and I are the same. We've got the same brain.
Now, I'll tell you something.
Yeah. Oh, you trumped me with your Martian soil.
No, sorry about that. My wife made me. I had to clean my office. I actually had years ago. I got a 5-gallon bucket full of simulated Mars soil, and I would give this stuff away. And now I'm down to maybe this much in the bottom of this big bucket. But
never give it away. Never give it away. Always keep a hold of that. Hey, listen, it's midday. Is it noon your time now?
It's noon. Oh, it's straight at noon. Okay.
We are so on time. Listen, you've got another session to do, and I'll talk to you after your next session. But I'm going to just say thank you so much for being here. It's wonderful to talk. Your energy is terrific.